Hello, my dear students, and the rest of the learners. Welcome to part 31 of a 37-part series of tutorials in computer structured programming in C and Pascal. This is section 10 of 13 in the topic data structures. My name is Meme JM, or you can simply call me EMELISWAP. In this tutorial, I'm going to look at a data structure that we call linked lists. I'm going to look at the introduction, linked lists. Then we shall look at categories of linked lists. Then advantages of linked lists, as well as disadvantages of linked lists. Then we shall look at the operations that are performed on linked lists. Let's begin by looking at the introduction of linked lists. Linked lists are data structures which are used in situations whereby the number of elements to be stored are not known in advance at the time of writing a program in order to avoid wastage of precious memory by allocating more memory than the required. A linked list is a linear collection of self-referential structures or the nodes connected by a pointer or pointer links, hence the term linked lists. A linked list is accessed via the link pointer to the first node of the list. Subsequent nodes are accessed via the link pointer member who is stored in each node. By convention, the last node of a list is set to null or nil to mark the end of the list. Linked lists are dynamic, so the length of a list can increase when an element is inserted into a list, either at the head, at the middle, or at the tail, or the list can decrease when an element is removed or deleted from the list. Linked lists become full only when the system has insufficient memory to satisfy dynamic allocation requests. Linked lists are not stored contiguously in memory. Logically, however, the nodes of a linked list appear to be contiguous. A linked list is a collection of nodes whereby each node contains the information on data and link field. The data field contains an actual value to be stored and processed, and the link field contains the address of the next data item in the linked list. The address used to process a particular node is known as pointer. So, elements in a linked list are ordered by their logical links, that is, addresses stored as part of the data within the node itself. The link field of the last node contains null or nil rather than a valid address. It is said to be a null in C or a nil in Pascal pointer, and indicates the end of the list. A linked list without nodes is called a null or empty linked list, and the value of the external pointer for it will be 0. That is, start is initialized null. So, elements in a linked list are ordered by their logical links or addresses stored as part of the data within the node itself. The linked field of the last node contains null or nil rather than a valid address, just as I have said. It is said to be null in C or nil in Pascal pointer, and it indicates the end of the list. A linked list without nodes, I have said, is called a null or empty linked list, and the value of the external pointer for it will be 0. That is, you initialize start with null. An external pointer is a pointer to the very first node in the linked list, and it enables us to access the entire list or the entire linked list. The first element or data in the list is usually indicated by a pointer called the head, which also refers to the first node in the list, while the last element in the linked list that has no successor is said to be the tail pointer in the tail node. Because the elements or data in a list can be of different data types, linked lists are thus essentially records or structs with several fields, but with either one or more of these fields being the pointers in the next node or nodes. So how do we categorize linked lists? So the four main categories of linked lists are: one, linear or singly linked lists; the circular linked lists; the doubly linked lists; and circular doubly linked lists. Let's look at linear linked lists. In linear linked lists, each node has two fields, one for data and the other for the link, which serves as a pointer to another single node, that is next record. It can be represented diagrammatically as follows. So we have the start node, which has data link. Then we have the second one, etc. And the last one has the reserved word or the element called null. So start is the head pointer. That is the head pointer. And then the second or data or link node is called the head node. The head node. And then at the very last, at the very end, we have what we call the tail or last node, and it has the special value null. So as you can see, each of the nodes or each record has the data, and one of the elements in it is a link, which ordinarily is a pointer. It is accommodating or holding the memory address of the memory location where the next data or next record is going to be found. Its syntax in C can be presented as, so we define a struct called node, and it has the following members. One of the members is a data of type integer, and the other one is a pointer to the next record, a pointer to the next record. And this record, I'm calling it next. So this pointer is called next pointer, pointing to the next node in the structure or in the struct called node. And then we initialize our pointer. We initialize our first pointer with null, or we store null in the memory location being pointed to by the pointer called start. We then declare a pointer. We declare a pointer called temp. We declare a pointer called temp, which is supposed to point to node. So here we are simply, let me rephrase this statement. Let me rephrase this statement to avoid ambiguity. This is simply a declaration of a variable, which is a pointer of type Note, this is a declaration statement for a pointer to the struct called node. So it is a pointer to struct, a pointer of struct, or a pointer to structure or to struct. So it is the one which is going to be used to refer to the elements of or the members of the struct or the structure called node. So this is a pointer, a declaration for a pointer called the temp that points to the elements of the struct called node. So simply, this is a pointer, this is a declaration of a pointer of type node, which is a structure. Well, the following is its syntax in Pascal. So we have the type node pointer, which points to node. And then node is a record. So node of type record. Then we also have another member called data of type integer. Then we have another member called link of type node pointer. That's the end. So this is a declaration of a pointer of the type we have discussed, or not of a pointer, but of a linked list structure. This is a declaration of a linked list structure, data structure in Pascal. So our linked list is called node pointer. It points to node, and it has the following members. One is node of type record. The other one is data of type integer. The other one is, another member is link, which is a pointer. This of type node pointer. So it points to the next node. And then end. And then here we declare a variable called temp of type node pointer. So we are going to use it to manipulate the contents of the record called node pointer, which of course also contains one of its members being a link to the next pointer or to the next memory location, being a pointer to the next memory location. Let's look at circular linked lists. This is a linked list in which instead of the last node containing an arrow pointer, it contains the address of the first node in the list. That is, the tail node points to the beginning of the linked list. It can be diagrammatically represented as follows. So you can see in this diagram that the last node contains a pointer which takes us to the beginning of the linked list. Its syntax is as follows in C. So struct node, one member being data of type integer, and then the other one is a pointer to the next node, which is struct node, then next. So simply, this is a member which is a pointer called next that points to the next node. Then this statement here initializes the content of memory location being pointed to by start to null. And it also assigns null to the memory location being pointed to by the pointer called start1. Let's now look at doubly linked lists. This is a linked list in which all nodes are linked together by multiple number of links, which help in accessing both the successor node and the predecessor node from the given node position. It provides a bidirectional traversing. Each node has two linked lists or linked fields that are used to point to the next successor node and the predecessor nodes. It is diagrammatically represented as follows. So we have our start node there, and it's followed by the head pointer. And then we have previous, then we have next. So this address, this portion of this memory contains an address. This address, we call it the head pointer. It points the beginning of the storage location. And at the same time, it contains an address which points to the previous node. And then it contains another address which points to the next node. So in other words, in this structure, we have two members. We have two members in each node, and these two members are pointers. One pointing to the previous node and another one pointing to the next node. And that continues all the way to the last node, which we call the tail node. And it contains what we call the tail pointer. Its syntax in C is as follows. I am declaring a struct called node. This struct called node contains one member called data of type integer, and another member is called previous, is a pointer to the previous node, and another member is a pointer to the next node. So I have two members here who are of type pointer. One is called previous. This is a pointer that is supposed to point to the previous node, and the other one is called next, which is a pointer that points to the memory location occupied by the next node. So both of them are members, but they're of type pointer. One is supposed to point to the previous, the other one is supposed to point to next. And then we initialize the memory location being pointed to by start to null. Well, the following is the syntax in Pascal. So type my linked list name is pnode. So I'm calling it pnode. So type pnode is a pointer which points to node. Then the members include node, which is of type record, or node equals to record. And then I have a previous, a member called the previous of type pnode. Then another member is data of type data type. Then another one is called next of type pnode. Then end. And then we declare an instance or an object that is going to be used to manipulate our members or the members of this data structure. And that member is, I'm calling that member variable name, and is of type pnode. Let's now look at circularly doubly linked list. This is a linked list in which each node has 3 fields, whereby the first field of the first node contains the address of the last node, and the last field of the last node contains the address of the first node. It's diagrammatically represented as follows. So that's how it looks like. As you can see, my dear students and the rest of the learners, is that each node contains a link pointing to the next node and to the previous node. Each node has one member pointing to the next node and to the previous node. And therefore, like in the first one, the last member called link is pointing to the memory location for the next node. And at the same time, that same member in the second node contains a pointer pointing back to the previous node. And that continues all the way. And the very last node contains 3 pointers, where one pointer points back to the previous node, and also another one points back to the start, the very first node, That's why it's called circularly doubly linked list. Each node points to the previous node and points to the next node, and the last node points back all the way to the first node. So its syntax in C is as follows. My struct name is node. So struct node, it has one member called data of type integer. Then it has 2 members of type node, and they are pointers. One of them is a pointer called previous, and one is a pointer called next, and they are of type node. And of course, they are structs. They are part of the struct, or they are supposed to manipulate content of struct type. Then we initialize start with the value null. We initialize the memory location being pointed to by the pointer called start to null. What are the advantages of linked lists? Linked lists can grow or shrink during execution of a program. They have efficient memory utilization because memory is allocated or deallocated whenever needed. Number 3 is that insertions and deletions are easier and efficient. Number 4, many complex applications can be easily carried out with linked lists. What are some of the disadvantages of linked lists? Number 1, if the number of fields are more, then more memory is needed. Secondly, access to arbitrary data item is a little bit cumbersome and also time consuming. So what operations can we perform on linked lists? Number 1 is creation. This operation is used to create a node as and when it is required. Number 2 is insertion. It is used to insert a new node in the linked list at a specified position. Number 3 is deletion. It is used to remove an item or node from the linked list. This can be done from the beginning, at a specified position, or even at the end. Number 4 is traversing or display. This is the process of going through all the nodes of the linked lists from one end to the other. Number 5 is searching. This is the process of finding the existence of an element in a linked list. Number 6 is concatenation. This is the process of appending or joining the second list to the end of the first list, consisting of number of nodes. And with that, my dear students and the rest of the learners, we have come to the end of section 10 in the topic data structure. You can continue to section 11 of that in this topic so that you can learn more about the next data structure. Congratulations for learning section 10 of 13 in the topic data structures. You can also access sections 1 to 13 of this topic, other topics in the computer structured programming unit, as well as other computer or ICT videos by clicking or tapping on EMELISWAP ICT YouTube channel below this video. You can also visit EMELISWAP Life Skills YouTube channel for free life skills, motivational, and inspirational resources. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emeliswap@gmail.com. Thank you very much for listening to me. Let's meet in the next part of this series, and God bless.